I want to start by first just giving everyone the opportunity to introduce who they are and what they're doing and where their focus is in the realm of hash rate heating and Heatpunk and Bitcoin mining heat reuse. Sometimes we call it hash rate heating. Sometimes we call it reusing heat in a Bitcoin mining operation. So just a little color on that in regard to what you're working on in your background, and then I'll start throwing some questions out.
Hey guys, it's great to be here. I'm Colin. I'm from MintGreen. MintGreen is obviously, like a lot of these companies, a company that's focused on heat recovery systems. We're kind of in some respects, the granddaddy of the space. We kind of came up with some of the first items that hit the news with some of the projects we were doing in North Vancouver. Our immersion systems, right now we have, I'm sorry, I'm doing bad here. All good. We have an immersion product called Digital Boiler that can be containerized up to 480 kilowatts. But I mean, our entire focus is technology and heat recovery, and we were kind of at you have to be the cutting edge of a lot of things for this space because your customers aren't necessarily savvy on Bitcoin. And so you have to understand sort of market theory, the hash rate, how that functions in terms of a distribution of revenue. And you also have to start thinking about like what terms are resonating with them. So there's a lot of things you got to capture with that.
Hey everybody, pleasure to be here today. Stoked to be on stage this year. We've got a 2.5 megawatt heat reuse project in Kirkenes, Norway. That's what I'm going to talk to you guys about. But SAS Mining, co-founder and CEO here. What we do is we do mining as a service. So we're a tech company as opposed to traditional hosting, and have built that platform that makes mining accessible to the masses. So competing with the Coinbases and Krakens of the world for how folks acquire their Bitcoin in a sovereign way. So people get wild sats through us, and we never touch or custody their Bitcoin, but we do get it in an aligned interest way, meaning we only generate Bitcoin for ourselves as our revenue if clients are generating Bitcoin. And we do that in Kirkenes, massive, well not massive, 2.5 megawatts, it depends on your scale, but 2.5 megawatt site up there that is heating a building, and talk more about that a little bit later here.
Matt Carlsson, I'm an engineering consultant in the industrial, commercial, institutional space, now working with miners to help them navigate and tap into this large-scale heat off-taker market, and then at the same time introducing my network on the other side, the off-taker market, to the concept of hash rate heating and the value proposition there, and playing a bit of a matchmaker role.
Hey everybody, first of all, thank you Tyler, thank you to everyone that put on this event. This is my first time here, so it's exciting. Looking forward to meeting you all and seeing what you're working on. So yeah, excited for that. My name's Christian Sartori. I am a digital energy developer at Mara, a public Bitcoin miner, and I helped lead the project development and stood up our 2 sites in Finland. So I've been over there a couple times to help stand up and build those sites. One is 1 megawatt, the other one's 3.5 megawatts, and those are district energy and Bitcoin mining sites. So excited to talk to y'all.
What's cool about this panel is we have people from publicly traded companies, large-scale mining operations, enormous, megawatts, gigawatts, as well as hosted mining companies, a different model from Kent here, all the way to the heat recovery with Colin. One of the things I wanted to ask you guys is like, are these heating operations or are they mining operations? Meaning, how I really frame that in my mind is the duty cycle, how long they're online. And so I think it's probably similar answers down the line here, but I'm curious for Colin to start, how you're framing this. Are they always online? Do you frame it as maybe to your clientele, it's a mining operation, or I think we were communicating a little bit as we prepared for the panel, like you frame it as a heating application, and how much do you tell them about Bitcoin? I'm spitballing here, but I'm really curious. Let's just start with like, step 1, mining operation or heating operation, who you're talking to and your customers, how are you describing it to them? I think that'd be interesting for the audience to hear.
So MintGreen's business is 80% customer owned and 20% MintGreen owned. This seems to be the arc of how things are working with us. So if it's customer owned, the Bitcoin is extremely important to them. If it's owned by MintGreen, in that case, they're getting low carbon discount heating, and then the heating is more important. That said, when you're dealing with, specific processes where they need temperatures to be at a relatively high temp continuously, they're absolutely heaters for that process as well. So the answer is kind of both, but they must perform as heaters always.
So I would say, the site in Norway is one of 4 that we've got. We're in Norway, Ethiopia, Paraguay, and South Dakota right now. And in all of those sites, when you're approaching the local community, Bitcoin is a bit of a loaded word, and you generally don't lead with it, right? So all of these are data centers with compute, right? In Norway specifically, we went into this particular site specifically because of the heat reuse, because we saw that it would help us be able to have some regulatory resilience, right? When you're providing a service such as heat, you're going to be less likely to be attacked by regulators if they decide to turn against Bitcoin mining generally. So it was a way to diffuse the jurisdictional risk, because we did perceive at that point in time, and it's now come to pass, that there was going to be some changes to how data centers were regulated there. So it's very much a, hey, we're going to bring in a data center here. We're going to help replace the oil boiler that you've got, so you've got cleaner energy heating your facility here, and don't look behind the curtain as to what we're doing with all that compute.
Yeah, I think in a way, heating is kind of the Trojan horse for getting into jurisdictions where Bitcoin mining is not popular, and that's a lot of jurisdictions. That's probably most. So if you're just looking to plug in X number of megawatts and you're looking for a PPA and that's all you're doing, you're going to be sort of pushed to the back of the queue. If you lead with heating, that's a useful thing, and then who cares how that heat is produced, right? It's I kind of look at the market. If you look at the quadrants of like, if you customer from like Bitcoiner to no coiner, and then commercial operation to hobbyist, the biggest piece to tap into, the biggest quadrant, is probably the no coiner commercial operations, right? And then you're selling heat. Like that's the business. How you do it, that's your business.
Yeah, I would agree with everything everyone said here. To echo what Kent said, I think in the Nordics, I guess pretty much in any jurisdiction, but generally you want to lead with heat as the primary solution that you're solving. And in fact, sometimes Bitcoin is a bit of a dirty word depending on who you're talking to. So when we interface with the municipalities or the district energy companies, we very much lead with, how can we solve your problem? How can we help provide heat that's cheaper than, and just as reliable as the way that you're producing heat now. So in Finland, a lot of these district energy companies are producing heat right now with, burning biomass or hydrocarbons, and and so there's different motivations to maybe shift away from that, and so we can provide that and just say, hey, we've got a data center that can provide that heat capacity to you. And sort of de-emphasize the Bitcoin part if needed.
Yeah, and actually another interesting piece of that seems to be the common approach in Finland, no matter who's doing it, because there's now at least half a dozen other projects there, if not maybe upwards of 10, sort of similar scale, low digit megawatts, but it's not a Bitcoin mining company that's providing this service. It's an independent third party, engineering firm. So they do the full gambit from, design, procurement, whatever. They stand it up, and then they operate it. So it's kind of like no headache for whoever the off-taker is, and the word Bitcoin doesn't need to come up.
To just tack on to what Matt said there, you really hit on a good point here, right? This is an engineering consulting firm that's helping put this together. This is a barrier to entry you have to pass, because essentially you can't just have the product. You have to know how the product fits in with their process. You have to have a pretty strong engineering team if you're going to be selling these or offering this service at scale. It needs to be supported end to end like any other EPC would. And you know, once we developed the product, that was a major eye opener for us. It's like, okay, so just can you quote this, you know, construction project? And it's like, oh God, okay, we need to hire some people.
You mentioned something, Christian and Matt, that I want to touch on, the word data center in your framing. How does this large-scale heat offtake operation compare to AI HPC? Is it even possible? Is there a unique nature of the Bitcoin protocol that makes this much easier in these applications from your research and deployments? Can you touch on that a little bit? I'm really curious to hear.
Sure, yeah. Yeah, it's a great question. I think there's a lot of components to that. Generally, Bitcoin mining, I think, is very well suited, at least for district heating. You know, you get up to pretty high temperatures these days. The newest generation machines can get up to 75, 80 Celsius at the outlet. And that is sort of ideal, at least for the Finnish district energy networks. And you know, it's also interruptible, very flexible in a way that AI HPC isn't. So that's, I think, a really good thing. But it can also run at 100% uptime if needed, right? The other thing that maybe we could touch on, I don't know, later, but it's something to keep an eye on the AI HPC front is that even though traditionally those servers have not been able to get up to a high enough temperature to be really applicable, at least for certain district energy applications, I think NVIDIA recently, you know, announced their Vera Rubin, you know, GPUs are going to be able to take up to 45 C inlet temperatures. So now we're getting up into some higher temp heat regimes, you know, not quite as hot as Bitcoin miners yet, but it's sort of trending in that direction, and that's all driven by, you know, trying to save on cooling costs and cooling architecture. So that'll be interesting to keep an eye on. But for right now, Bitcoin mining, I think, is very much a differentiator in terms of the heat quality and the heat output that you get.
Yeah, and it's one of the things you have to sometimes educate people on, because if you do say, you know, data center waste heat or whatever, they might already have an idea about that, and it's actually kind of a crappy partnership. Data centers, I mean, besides the forget air cooled, and then besides the fact that it's whatever, you know, half the outlet temperature, so nowhere near as useful. Most data center companies don't want to enter into an SLA, they don't want to actually get into an agreement that's binding that means they have to provide heat, right? So suddenly it's not that useful, and you don't have customers using your Bitcoin mining ASICs. You're just mining, so you can run it to match the, you know, the heat load, that profile. Whereas, you know, if it's AI HPC, it's only producing heat when people are using it, right? So it's a totally different game, and you can't really guarantee that at all.
To Kent and Colin, another thing that I think is interesting on the large-scale applications is this idea, this notion of matching hash rate to heat demand, sizing for the off-taker. And I'm curious, you know, is there, and we'll work our way down all the way, you know, is there an upper limit to this? Probably that's a question that Mara might have to keep in mind. You know, as a large publicly traded company with enormous sites, there's only so much heat that can be delivered and sent off. You know, I'm curious, as we work our way from Colin down, you know, what is the size that you see common? Is it well suited for hosted operations, Kent? Is it well suited for, you know, your specific custom systems where you're designing hardware and control software specifically for these applications? And then after you comment on the sizing, we'll get into, you know, what kind of applications this actually looks like in the commercial industrial space.
That's a complicated question. The fact is, it's both, right? I mean, like, it's an economic question, and it's an ownership question. So, obviously, the more offtake you can get, the more economically strong the project is, provided you can get a good price for the heat that you're offering, which is jurisdictional. We find that we've seen both. When there's an end user with a good energy price, they're less concerned about 100% utilization, and they're happy to have some peaking boilers and then maybe take a more significant load than a base load from Bitcoin mining, because even if they reject the heat, they're still profitable. And so they go from immensely profitable to profitable, and that's completely manageable for them. We quoted a place in Scotland. It was like a municipal building and a pool. And Scotland has horrendous energy prices. It was like 30 pence a kilowatt hour. But their natural gas was also very expensive. It was on the order of, when you convert it, about 25 cents a kilowatt hour. So there's like a savings there with Bitcoin mining that actually makes it make economic sense. But that's only if the user is obligated to heat. So I don't think Mara or anyone else here wants to necessarily own that facility, because then you must be the utility, you must be charging for the heat. Maybe that's one day. But the reality is, for something like that, it's like it makes sense for them because they're losing money constantly on this, or they're charging their customer a lot and can pass that savings on. But where if you know a Bitcoin miner or a company that's developing Bitcoin mining technology in this way wants to own it, it has to kind of stand on its own two legs, and the actual sale of heat has to make it so it is actually profitable, not just a savings.
So it is a complicated question. Thank you for saying that. Let me first tackle the hosting versus self-mining. I actually don't think that there's a distinction between those two. It's largely the same. Our client's equipment is in the data center, so 2.5 megawatt data center, and it wouldn't matter if it was our equipment or theirs, how we conduct and manage the heat side of things. So the data center, let me get into some specifics, because I think the answer is actually application specific. And general rule of thumb for the heat reuse sites we've looked at, 20 to 50% is kind of the offset that we've seen. In this particular site, it is hydro-cooled machines. It's a closed loop that goes to a radiator to another loop that runs through the building. And this building is an old renovated hospital that's been converted into a business center. So by coming in and building this data center, we could eliminate an oil boiler. There's still a backup system there for backup heat, but we do have an SLA to deliver heat, right? And the interesting part is mining actually for us comes first, which means that the heat is always there, which means when you get to summer months, you actually need some way to disperse the heat, and that comes through a dry cooling system, right? So the heat is there, it's just how much economic value we can extract depends on the heat demand of the facility, and automating all of that operation is where the complexity comes in, and a lot of trial and error to get there. So as far as the distinction between hosting self-mine, I don't think that matters, and I think the limit on how much heat could be applied is actually really on the demand side, and the bottleneck there is operationally the skill at the controls to shunt the heat around as well. That's quite complex to do.
And then to the first part of your question, I think that you can find heating applications that are absolutely massive, 100 megawatts, but really what you need is a base load that you can run year round. So there aren't that many applications that, say, need a ton of heat in the middle of July. So that's kind of what you're sizing for, and sort of doesn't matter what that industry is, that's going to probably be, most of it's in the single-digit megawatt range. So it comes down to, the business model, whether it's hosted or self-mining or whatever, it comes down to the scale of capital deployment that company is happy with. Are you happy to build a 5 megawatt mine? Then, that's perfect. If that's sort of peanuts, then, it might not be a great application. But it is a great way to distribute mining, that's for sure.
Yeah, I think that's really well said. It's essentially very project specific, and as everyone up here said, it's really limited by your heat demand and sizing your project to the heat demand. So as Matt alluded to, in Finland, we sized our projects to the baseload heat demand throughout the year. So, there's probably an 8 or 9 month heating season where a lot of heat is needed, and then in the summer months, you still have kind of baseload hot water demand. And so we size our systems to those summer months, and we're able to kind of optimize for utilization and being able to run all year round and at kind of max capacity. And that also allows you to kind of minimize your spend on cooling infrastructure. At one of our sites, we actually don't even have a dry cooler because it just runs straight into the district heating network all year round. So
That's like a preheating scenario where you don't need a dry cooler because you're just pumping into that district heating setup consistently.
That's right, yeah. And so for our projects, they're a year and a half old now, and at the time, we didn't have miners that we were comfortable with getting up to the temperature required for the district energy systems. Now that's changed, and I think you can go kind of direct. But we have a heat pump system, which not a huge fan of in an ideal world, but we have a heat pump system that kind of boosts our heat to the required temperatures for the district heating systems. So yeah.
This Finland site you're talking about is heating homes, right?
That's right, yeah.
For those of you who aren't aware, how many homes are being heated by Bitcoin miners?
It's somewhere around 65 to 70,000 residents across the two towns that we're in. Now, we're not the sole provider of heat, but we contribute significantly to that.
That's amazing. One of the things I want to talk about next is the idea of co-location. These sites you guys are talking about, a common thread I see is, well, I don't think I have district heating here where I live in this neighborhood. This building certainly doesn't have it. Why is it the Nordic nations? Why is it Finland? Why is it Canada? I imagine it might have a lot to do with the duty cycle, the heating season, how long it is. And then also on that note, how far can you send the heat? How do you have to place these actual operations compared to your off-taker?
I think you'd be surprised how many of these systems are in, like, the U.S. alone. There's probably at least 1,000, because they're not necessarily municipal systems. They could be smaller systems that serve a hospital campus, government campus, university campus. Nearly every single one of those has pipes in the ground with steam or hot water, and sometimes cold water, chilled water. So they're kind of everywhere, and those are perfect applications too. So then it just comes down to, understanding, well, their system, but understanding their procurement process and, like, how do you get a conversation with them going.
I'd say that's very accurate, Matt. I mean, the United States has lots of DE. Again, it's more campus specific. But to answer your question about the distance, I think what you have to be careful with is, right now we're working with the mayor of Vancouver to heat a large outdoor pool called Kitts Pool. It's like 100 years old. They're redoing it. And the problem is right now, it's going to cost something like $250 million to build. But they're only be operating for 4 months because of the cost to heat it, because they banned anything but electricity in the city of Vancouver. So the mayor happens to be a big Bitcoiner, which is great. We're texting all the time. I'm meeting with him when I get back from here. But there's also so we got to provide basically a peaking load to this system. So it's like 2 megawatts this pool, so they can stay open. Call it 360 days a year. But then you have these shoulder seasons where you have a ton of heat that's low carbon, and where's it going to go? Well, about 900 meters away, we can connect to a DE line for a new building called Sanok that has 4 million square feet. And in BC, the cost is about, in Canadian dollars, about $1,000 a meter to connect. So it's about $1 million, or maybe $600,000 US to connect to this thing. And that the economics of it are actually strong enough to do that. Whether it's not likely going to be us specifically involved in that, this is actually probably going to be taken over by a foundation that supports the pool itself, and they kind of will be able to have this trust of Bitcoin that's going to be able to support, community projects, engagement, and swimming, which is really interesting. But the distance is a question of economics. These pipes are extremely well insulated and can travel for miles, but they are expensive.
Expensive to put in the ground. I think the co-location piece is really a huge part of the value prop, because you've got power and walls and a roof, and like that's a great start. So if you care about deploying quickly, which most people do, that's sometimes easier and increasingly true than going hunting for PPAs, for just mining.
I want to talk a little bit about the actual hardware and software involved at the machine level. The last panel, the product guys were talking about how difficult it is for them to get these things certified in more residential, smaller commercial applications as heating systems because they don't know what's under the hood in these black boxes. In the data center application, Bitcoin mining operations, that doesn't seem to be a hurdle. Otherwise, these things would have already been certified. I'm curious, are you running into any limitations for this type of application with heat offtake where you wish there were changes in the hardware, you wish there were changes in the software for control? It might be different if you have a dry cooler outside and you're just going to shunt the heat anyways. Maybe there's a site where you wish you could just throttle it back because the heat is so lucrative and you don't want to run them when the heat isn't in demand. I'm curious, what ideas come to mind when we talk about this? Because you, Colin, to start, have started building your own system. So let's start with you.
So this is a really interesting question. So on the certification side, you have to be careful because you are a heating system, but you actually don't want to be a heating system. And this is actually fairly easy to skirt because waste heat recovery is treated totally different than, say, a boiler is. So we sometimes get ourselves in trouble because we call our product a digital boiler, when in fact it is a waste heat recovery system. So that's a marketing term that is not what it actually is. So that distinction is very important because there's a lot of impetus to recover waste heat in a variety of ways. It's looked upon very positively, whereas building a boiler needs a myriad of certifications and is a lot more challenging. So in our case, we're doing things a little bit different. So there's nothing off the shelf with what we're working with. We've taken basically what we found to be the most heat-resistant miner on the market. We've reconfigured it in many ways, software. We have our internal system, we call it a magazine, which just has interlaced miner parts in sort of a line that pulls dielectric fluid through it. And we were able to get, with very high flow rate, very nice temperatures. But our next challenge, we've kind of pushed that to the limit. Our next challenge is we need to acquire cores. We have a good lead on that. We're going to start building our own boards to push those temperatures even higher. We want to avoid using heat pumps wherever possible and maximize the temperature we can get from it with the stretch roll to be able to create steam from these systems.
So we work in partnership in Norway, and our partners there, they first got off the ground with heating greenhouses in Amsterdam, where they worked on several sites. And I would say the bottleneck is, I think eventually it'll be standardization of this technology, but I think we're still at the point where we're still kind of in tinkering land, and every new data center is another at-bat to figure out how to build the control systems a little bit better in a little bit more of an automated way. So for instance, this is, I think, about the 19th data center of this type that they've developed. And they're still tinkering around the edges, and it's very application specific to figure out how to automate the heat side of things because that side is much more complex to automate through digital controls than the actual mining operation itself. So I think at this point, I don't see any specific limitations to that need to be removed so much as just operational bottleneck and more learning experience. But eventually, I foresee that we will have some standardized solutions that will be more out of the box plug and play that comes as a result of these efforts.
Yeah, I don't have a lot on this other than integration. System integration is key, and right now a big hurdle. Connecting to a commercial BAS system. That's, I don't know how many projects out there have done that successfully. Possibly none. Maybe not too easy, but it means you gotta support it. You gotta have somebody nearby all the time.
Yeah, I don't have much to add to what's already been said. I think that it's true that a lot of the controls and the sophistication around integration with the heating and plumbing of the systems are still being iterated on, and I'd like to see better kind of systems integration, particularly with just the district heating energy network and the power sort of like being able to more seamlessly, like, I guess, trade around power and ramp up and down with demand response of your data center, et cetera. But yeah, it's still very, I think, early days in terms of controls and a lot to be improved.
All right, last question, and we'll work our way back down, starting with Christian. How lucrative is the heating product of this two-product system, heating and sats? And the further point is, does a lot of large-scale mining operations start to off-take heat, sell it as a product to survive through subsequent halvings?
Yeah, I think that in general, we try to target places where Bitcoin mining heat is going to be the best alternative to what's already in place. So, in the district energy space, depending on what your feedstock is already, there's a production cost associated with that, and we have to do kind of the economic question and analysis of what is Bitcoin mining heat going to be able to provide that in a less expensive way. And so, again, as it turns out, in many applications, hydrocarbons are actually a pretty good source of heat. Pretty, BTU dense and cost effective. So it's hard to compete with that in certain applications. But in others, whether, the system needs to maybe be upgraded or electrified, and expensive, electric boilers or something are the alternative, and there's a CapEx investment there that needs to be made. I think Bitcoin miners can come in and say, how about we provide you even less expensive heat, and you don't have to make that huge capital investment. We can come in and do that instead. That's a compelling case. And so, yeah.
Yeah, there really is no standard sort of price for heat necessarily. It really is very jurisdictional dependent. So, yeah, you really have to understand what the energy costs are and what the sort of incumbent systems and fuels are you're trying to displace, and then at the same time, the motivations of people. So even if gas is cheap, for example, which in most places in North America it is, there are still a ton of customers, potential customers at the sort of institutional level who are still trying to electrify anyway. They're trying to find electric solutions. So you can tap into a whole market that is already willing to pay more for electricity. Then you just have to sort of run the numbers against some type of heat pump, whatever variety that is. But then there are pockets where people are using bulk fuels that are shipped in, or whatever, remote areas where that's expensive and they would love to be able to use their cheap hydro. You really just have to, look at all the little pockets of energy and the different types of people who are there and figure out what you can sell the heat for. And a lot of times, so the best opportunities there, a lot of the times it makes sense. It's worthwhile doing, and I think it kind of sets a floor price for the miner, where an uncorrelated revenue stream, which is kind of nice because hash price doesn't do what they say it's going to do on Twitter.
Does it ever? So I just to give some quick numbers, I ran the calcs on that, and the heat offsets about 30% of the electrical OPEX for us at this site in Norway, just to give a specific data point there. I think it's absolutely necessary for heat reuse in the European Union now. I don't think you can mine. There's not much mining that occurs in Europe, period, because the electricity price is already so high. And I would argue that's why you see the large-scale data center heat reuse model is coming out of the European Union, is because both regulation, the heat reuse sort of protects you from a regulatory standpoint, and electricity price is so high, so they've been forced to innovate. And so I actually think a lot of the leading companies that are doing heat reuse at an industrial scale are coming out of Europe specifically, and I think that will continue to be the case unless Europe changes trajectory. So is that the future everywhere? I don't know, but certainly as the margins for mining continue to get squeezed, which seems inevitable as hash rate continues to go up, we will need to compete at a further and further scale, and I think heat reuse is one of those that just seems a no-brainer.
So when you're talking about, where is the money? The district energy industry is about $280 billion. I think if you added up all of the market caps of the mining companies in the world, I mean, maybe you get to 60 billion, maybe it's less than that, 28, something like this. So the heating market is massive. These groups are heating. They're generating no other revenue source but selling the heat themselves. In Vancouver, I know the largest heating utility is selling heat at about 14 cents a kilowatt hour US. And out of the wall, our energy from our LGS, or large general service, there is about 6. So they're tacking their amounts on. You can put yours on. It stacks incredibly well. And when you say, it doesn't compete with hydrocarbons, well, hydrocarbons, just like all other heating sources, generate no revenue onto themselves. It's a bottomless money pit. So it's like same with heat pump. You can lose money slower. Or you can potentially actually have a revenue positive project. Like net negative heating is mind-blowing to this industry. And it's distinctly possible in many jurisdictions.
Let's give a round of applause, sorry. Round of a hand to everyone here.